Hi, Megan.
Hi, how you doing?
I'm doing great. How are you doing?
Good.
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 Glad to hear it. Okay, so a couple just housekeeping things. I will introduce you at the beginning, but I'll take just 1 minute to take people to the CCEH website to remind them about funding opportunities and core facilities. Just like it'll take maybe a minute of that. And then I will be very brief in my introduction of you, just talk about you as a postdoc for Hal and your training just really briefly. And then I'll turn the time over to you. We record these, is that?
That's fine. Yeah.
Okay. And we post them on the website so that people can go listen to
I've
them.
rewatched them a couple of times myself, so yeah.
Good. That's actually the whole purpose of it, is that you heard it, but you might have missed some things, and so you go back in and listen. So that's great. In these, we have had kind of different styles for different speakers. How do you feel about questions throughout or questions at the end?
I'm fine with them throughout. I mean, this is not really much of a science presentation, more just talking about Hal's contributions to the field. Yeah. So, but yeah, it's totally fine. They can interrupt. I don't mind that at all.
Yeah, I actually think I think in both cases, it's more fun because if it's more of a, rather than lectureship, it's more of a learning process for everybody when they can participate. So I will invite people to populate questions in the chat and then just ask them to jump in and ask them when I see them, if that's okay with you.
That's fine.
Great. Okay, so that's all the housekeeping stuff. Let's just make sure, let me make sure screen sharing is on. And let's just test your screen sharing right now. Yep. Wonderful. So that's it. It's up. That's not in presenters mode, but that's another.
Yeah. I presenter mode. I just needed to switch my display setting to swap screens. There you go.
Yes. That'll be perfect. So let me ask you to unshare again so that I can share my screen for the introduction. Yeah. Okay. And we've got 10 minutes. So it typically or not typically, I never know how many people will attend these things. Sometimes we get 10 or 15 people. Sometimes we get 100 people. And I just never know. And either way, it's going to be great because I really appreciate you doing this. Hal made such huge contributions to the field. I think it's important to honor those people. And you guys have Eddie retiring too, so we may have to do something for him in the next year.
Yeah, we've been talking about doing something, a surprise for Eddie or a small get together just for the CCH people over here for him, because we hadn't heard if the IU was doing anything for him. He's been with them for over 30 years, but we hadn't heard any word. So we were like, well, we'll plan something smaller ourselves. And then it turns out they're doing it too. So we're having 2 celebrations for Eddie.
Okay. Yeah. That's okay. I mean, I still think that I'm trying to think about in the history of the CCEHs, have we done this well? And I would say not so much. And I think we should do it better. And so I'm excited that we're doing this for Hal, not excited about why.
Yeah.
But I think it sets a really good precedent to show the contributions of these major players in the field and, that they're remembered. Yeah, that's cool. I love that. Okay, so we'll just kind of let people populate in here and then we'll ask about participation in that and go from there. Okay. I've got it recording right now. I'll probably trim this. Okay, I think we'll get started. I'm Diane Ward, and I am the enrichment coordinator for the Centers of Excellence in Hematology. And I want to welcome all of you to this month's Meet the Expert seminar series. We're really delighted to have Maegan Capitano talk to us today and honor Hal Broxmeyer, who has been a major contributor to the field of hematopoiesis and we'll give her all the time that she needs. I'm going to do a couple things. I want to just do a little housekeeping here. First of all, I want to ask those who are not speaking to please mute themselves so that it doesn't disrupt the presentation. And if you're not muted, I'll kind of scroll through and try and help you with that if you need it. Maegan has agreed to answer questions throughout the series. And so I would invite you, you can either unmute yourselves or populate questions in the chat, and then I can invite you to unmute yourself to ask questions anytime during the series. And we hope this will be a really good sort of exchange in honoring and remembering Hal. The second thing is we are recording this, so it will be available on our website for you to go back and look at later if you're interested in that. And to that end, I want to share my screen. I'm going to get there to take you to the website. This is our Cooperative Centers of Excellence in Hematology website. This is the home page, the landing page, and there are several things I want to show up to you. We show upcoming seminar series that are happening. Maegan's today, but you can also see opportunities for funding, careers. There are postdoc jobs populated here if you're looking for a postdoctoral position or even a technician position. And then in the funding section, if you click on that, what you'll see is current or past funded individuals, but application calls. Right now, we have two types of applications, type A and type B, pilot and feasibility monies. The type B awards applications are closed right now. We just in the next week, we'll be announcing those new recipients. But type A awards are available for it, that you can apply for anytime. And what these are up to $12,000 of credit at a core that's funded and supported by the Centers of Excellence in Hematology, the U54 mechanisms at any institution that you can apply for. And I highly encourage you to go look at this because it's, as we like to call it, kind of free money if you have a really good proposal that could use some important preliminary data using a core that's available through the Centers of Excellence. I'm gonna stop sharing there. And then I'm just going to introduce Dr. Maegan Capitano. Maegan got her bachelor's degree at St. Mary's Honors College in Maryland. Is that different than a St. Mary's? I've never even heard of it. So
yeah, it's the Honors College for University of Maryland.
Okay, thank you. Cool. Okay. She then went on to get a master's degree at University of New York at Buffalo, and then her Ph.D. in microbiology at the University of Buffalo. She then moved to a postdoctoral opportunity in the lab of Hal Broxmeyer, looking at experimental hematology, where she has worked with Hal for several years and is currently an assistant professor in the Department of Microbiology and Immunology at Indiana University School of Medicine. And today, Maegan is going to talk to us about honoring Hal Broxmeyer. And we're so really appreciate it, Maegan, that you would do this for us. We want to honor those individuals in the field who've made major contributions to hematopoietic research, and Hal is definitely maybe the definition of that. So we'll let you go for now. We'll have the talk run till about 5 or 10 minutes till the hour. And then if there are more questions at the end, or people want to just show their face and talk, you are welcome to do so. And thanks again, Maegan.
Thank you. Me swap you. Okay, there you go. Thank you very much for inviting me today to talk about Hal Broxmeyer. Hal and I, Hal was my mentor for about 10 years. 4 years as a postdoc, 4 years as an assistant research professor. And he's probably one of the most influential person that's infected or has influenced my career. Those of you who know Hal pretty much know that Hal was a consummate lover of scientific history. So I treated today's seminar opportunity as a way to talk about the history of Hal Broxmeyer's career. In fact, anybody who's in Hal's lab knows that Hal was a lover of sharing his knowledge of scientific history by doing book swaps with the people in the lab. So often you'll find Hal leaving books on your desk with Post-it notes that talked about physics or about microbiology or about a variety of topics that Hal at the time thought would be interesting to read about. So let's talk about a little bit about the history of Hal through the collection of his security badges. And I want first to say thank you, Mark Kaplan, for helping provide and collecting some of these pictures for me, which I've added to. Hal started off his scientific adventure getting his BS or Bachelor's of Science from Brooklyn College. First, Hal started college wanting to be a math major. And anybody who knew Hal well would know that Hal was actually very good at math. Hal actually hand calculated most of the statistics for all the colony experiments he counted. He did all those calculations by hand. He didn't, even after all that stat software became available, unless Scott was analyzing the data for him, Hal did all his calculations by hand. Hal then moved on to decide to do biology instead, finding that more interesting. Moved on to do his master's in Long Island University. He did sort of a tour of all the colleges and universities in New York. He finally ended up getting his Ph.D. at NYU in 1973. And this is where you can really see, if you look up what Hal's thesis project was on, where Hal's interests were going to lie. Because his Ph.D. was actually examining neutrophil or neutrophilic-like leukocytes migrating into perfused rodent limbs, so rat and mouse limbs. And then he goes on to do his first postdoc at Queen's University, finally left New York and went to Canada, but then ultimately ended up back in New York at Sloan Kettering to do a second postdoc. And then finally to his final home in Indiana University. So I'm going to talk a little bit about his time at Sloan Kettering. Hal joined Malcolm Moore's lab as a research associate. So sort of a senior postdoc in Malcolm Moore's lab. And if, I'm sure, I mean, I see Lou Palos is on this seminar, who was at Sloan Kettering along with Hal. A lot of you guys know that Malcolm Moore was the one that discovered GCSF. And so you can see sort of why, you look at what Hal did for his PhD thesis research, that his passions then lie in a large way on how cytokines and chemokines regulate hematopoiesis.
Scenario, we just take our own, right?
Does somebody have a question? No. Okay. So Hal became a sort of a postdoc or a research associate in Malcolm Moore's lab, but he moved up through the ranks at Sloan Kettering. He was promoted to all the way up to associate member at Sloan Kettering, and it just so happened he was promoted at the same time as my uncle, Richard O'Reilly. And so I got to hear a lot about the process of the struggle Hal had to become an associate member in 1983. And I really actually had a great honor. One of the, I call it a fangirling moment in science. I went back to Sloan Kettering. I had worked at Sloan Kettering for a little while with Beau DuPont for approximately 2 years. And I was invited back to Sloan Kettering to go to attend a seminar with symposium on my for my uncle who was stepping down as the head of pediatrics at Sloan Kettering. And I went with Hal to honor my uncle. And I got invited to a dinner where I got to sit at a table with Malcolm Moore, Hal Broxmeyer, Richard O'Reilly, and Beau DuPont. And they talked about all about the history of all their major accomplishments, including the discovery of GCSF and the isolation of GCSF, and the roles that Hal played in understanding different inhibitory and activating growth factors and cytokines that regulated myelopoiesis. And the first, the initial talks about cord blood transplantations, which I'll go about in a little bit, and the initial allogeneic transplants and bone marrow transplants. And it was just a fangirling moment for me. I was sitting there with like bug eye, just amazed that I got to sit at a table with all these brilliant minds. But Hal was lured away from Sloan Kettering really early after getting promoted to associate member. And he was lured away by Ron Hoffman at IU. And so Hal joined IU in 1983. I was 1 year old at the time. And he joined IU already having sort of, as you well know, sort of already have an idea about looking at cord blood as a potential source of hematopoietic stem cells, but hadn't quite finalized that paper or that idea yet. He had been in talks at that time with his a collaborator at Sloan Kettering, many other collaborators, but his collaborator at Sloan Kettering, Edward Boyes. And Edward Boyes and him were discussing about ways they could potentially use cord bloods in the clinic, because at the time, they didn't really have an idea of the hematopoietic stem and progenitor cells, but there could be some use for cord blood, this huge source of blood that was just being tossed away. They had discussed possibly using it for a source of neutrophils or platelets or red blood cells for transfusions. But Hal really worked lab focused on understanding that there may be these transplantable hematopoietic stem and progenitor cells. So a lot of this work was done at IU with collaborators at different institutes such as Sloan Kettering. And I don't know if you've ever got to hear Matthew Farrow, the first cord blood recipient, talk about his experiences of Hal and how he imagined a scientist to be as a scientist who stares into fancy microscopes. But here you can see a lot of the pictures that were taken to be part of this Indianapolis Star news article about Hal Broxmeyer that was released shortly after the first transplant. You can see the obligatory scientific photo of the scientist with the mouse, the scientist with the microscope, even though he's staring at the plate outside of the microscope instead of actually sitting on the microscope, and Hal at the computer. And anybody who really knew Hal, that this is Hal would use a computer to look at emails or to search journal articles, but really without his right and left hands, April Maines and Scott Cooper, we wouldn't have a lot of Hal's typed out manuscripts, because Hal is not a big lover of technology. And Hal actually, right in here, this picture always cracks me up because Hal's quite allergic to mice as well. But Hal published this paper on the utilization of umbilical cord blood as potential source of transplantable hematopoietic stem and progenitor cells in PNAS in May 1989. But really, he held off on publishing this work, which was completed prior to this, until he can show that it was going to work in a human being. And part of this reason why is, a lot of people just, had trouble believing in these findings. And so he held off and published them closer together, the two articles closer together. And Hal had only, imagine or not, Hal had only been a faculty member for approximately 8 years at the time of this discovery. So let's talk a little bit more about this initial transplant. So Matt Farrow was the little boy that was received the first umbilical cord transplant based on Hal's initial scientific findings. His family took a chance on Hal. Matt Farrow at the time, I believe, was 2.5 years old. He was undergoing bone marrow failure due to Fanconi anemia. And his oldest sister at the time was not an good HLA match for bone marrow transplantation. His mother at the time, though, was pregnant with his soon-to-be younger sister, Dorothy. And an in utero test found that Dorothy was going to be a good HLA match. And so after talking to the doctors, they told him all about this potential life-saving treatment, this new technology that nobody has tried before, and that might give their son a chance to survive this bone marrow failure. And that is to receive these stem cells from an umbilical cord blood. So on a Pan Am flight from New York City to Paris in the fall of 1988, lugging a 25-kilogram container with frozen human cord blood, Scott Cooper and Hal Moore met in Paris by a doctor who agreed to take a chance on this procedure, a brave doctor, Elaine Gluckman, and who was an expert, had a very good survival rate with treating patients with bone marrow transplants with Fanconi anemia. Where this first umbilical cord blood transplant happened on October 6, 1988. And so this I took from an interview with Hal Broxmeyer that the IU School of Medicine did in 2015, that was interviewing Hal about this first transplant. And Hal was telling him that during those first pivotal days in Paris after the transplant, Hal was very nervous. And that he said he had to wait to see if the stem cells would take root. And he wasn't, Hal was always confident in his work, but he was nervous. And he had to wait to see if it could actually replace and repopulate the blood system. He said there was literally nothing I could do for him. I was just waiting like everyone else, and he was having trouble sleeping. And he was over in the corner of the room he was staying in was the big boy, this big liquid nitrogen unit that he was used to transport the stem cells. He said it was fuming gas into this room, making that wait even a bit more dangerous because nitrogen displaces oxygen, Hal said, and he had to keep the windows open so he wouldn't die from asphyxiation. And he was shivering with all the covers on top of him because it was cold outside. And then he finally he went back to Indianapolis, and only 3 weeks later he got a phone call notification that that Matt Farrow's blood count came back to normal, and that living first test had worked. And so Hal maintained a friendship with Matt Farrow throughout the rest of Hal's life. It's been now, I think, over 30 years since the original transplant. Matt Farrow and Hal stayed very, very close. Matt Farrow has lived, he said, a life full of love and happiness. And that life was provided to him by his family having trust in Hal's science and in the science of Hal and his collaborators, and Elaine Bookman for taking the chance on performing this first this cord blood transplant. Matt Farrow is now married and has a stepson, and his youngest sister is also having a very fruitful life. So several years after that first transplant, Discovery magazine put out a news article about this. I think by this time that this news article came out, 2 successful transplants had been done. And throughout this magazine article, there were quotes from Hal and Ted Boys that talked about the first transplant. And then if you read it on, they talk about the possibility of perhaps using these transplants for maybe recurrent leukemia and other stuff like aplastic anemia, which they thought may be a very good opportunity to utilize umbilical cord blood. And a grandmother of a patient who needed a transplantation had read this and approached the doctors about having this procedure done on this patient with leukemia, and they took the chance. At this time, John Wagner at Johns Hopkins in Baltimore was a medical fellow in Hemonk. He's now at the University of Minnesota, but he took the chance and performed this first cord blood transplantation on a patient with leukemia. And it was successful. And this was published back in Blood in 1992. I want to make a note that in this paper that was published in the 1990s, they talked about the possibility that stem cell transplantation may be used as a way to cure a patient's body of AIDS. It was a brief little snippet. And I just want to say that, this year there was a newspaper article in the New York Times about a woman that was cured of HIV using a novel treatment. And that novel treatment was umbilical cord blood transplantation. So in the field of UCP or umbilical cord blood transplantation, it has expanded worldwide with the estimated over 40,000 patients have subsequently received umbilical cord blood transplants successfully for hematological disorders and malignancies. And these were some pictures of cord blood recipients that were courtesy of CryoCell, who sent me these pictures. Also, so I'm sure many of you guys are aware that Hal Broxmeyer had won several awards throughout his lifetime. But Hal had never received anything that had moved him more than a book that was put together for him of pages and pages and pages of notes from patients and families of patients that had received umbilical cord blood that had saved their lives. Hal was so proud of that book. He kept it with him. He showed it to everybody. He gave everybody an opportunity in his lab to read it. He gave all his friends and families a chance to read it. That was probably, other than his family, one of Hal's most prized memorabilia. And yeah, I still remember reading that book and just sobbing because I've never, we all dream in the scientific field of accomplishing something in our career that can really make a difference. And very few of us ever get to do the point where we can save so many lives. And I mean, Hal got to know that his work has saved tens of thousands of lives. And that's a major, major accomplishment. Yeah. But not only did Hal make a major contribution to the hematopoietic stem cell transplantation field and the idea of this new therapeutic technique or a donor source of stem cells that can be used for transplantation, but he also greatly contributed to the idea of cryopreservation of these units for subsequent transplant. And how important this is, and the idea, because not only is cord blood a great source of donor cells because it doesn't require, as many of you guys are aware, as much of an HLA match as mobilized peripheral blood or bone marrow. But also because it's not going to be dependent on having to collect a sample right then. You can store it for over time and be able to come back to those units and use them later. So here's the initial equipment Hal used and Hal's lab used to test out the whole theory of freezing cord bloods for subsequent later use. And this all led to initial publication put out by Hal, Scott Cooper, and Zhao, who's a long-term member of Hal Broxmeyer's lab as well, that showed that you can thaw and recover cord blood cells that have been cryopreserved for up to 15 years. Later on, Hal group would go on to publish in PNAS and subsequent work in Blood that showed that 23.5 years later, you can recover that cord blood, and reuse it for and it still be functional. And honoring Hal's wishes, and actually I believe that experiment is happening this week. It's already been started, but they're analyzing the transplants this week in NSG mice. Scott Cooper and Hal's former postdoc, Jim Ropa, are continuing this project now with 30-year-old cord bloods and hope to have that paper come out. And there is their wish to honor Hal by trying to make sure that Hal can be first author on that paper. But as you know, this finding has garnered Hal many awards. And not just these findings, but it's a whole career worth of great scientific contribution. And it would take the whole hour to talk about every award Hal has won. But these are just some of Hal's many awards and honors. In 1991, so shortly after those first initial cord blood transplants, Hal became the president of the International Society for Experimental Hematology. He also won the gold medal from the city of Paris in 1993. He's won the Karl Landsteiner Award for the American Society of Blood Banks for his role in introducing cord blood banks. The Donald Thomas Prize for the American Society of Hematology, where he gave the award-winning lecture. He was the president of the American Society of Hematology, which I'll go into a little bit. He won the Donald Metcalf Award for the International Society of Hematology for Stem Cell Research, the President's Medal of Honor from Indiana University, and a Lifetime Achievement Award from the Cord Blood Association. One of Hal's, though, favorite things to talk about, well, at least one of the ways I was introduced to Hal, Hal was very, very proud to be the very first PhD to ever get to be the president of ASH. He was shocked by that. Let me share a little bit about the experience ASH with Hal Broxmeyer, because it was always a riot. As many of you guys know, Hal wasn't a very tall man. And so when you have the crowds of ASH, there's tens of thousands of people there, and Hal's a very fast walker, especially compared to me. It wasn't always easy to find him in that crowd. But Hal was very distinctive in his ASH attire. Hal always wore a nice suit, but Hal always wore white sneakers, very bright white sneakers. You can always spot Hal in the crowd at ASH by his very bright white sneakers. He was always talking to somebody, always. And he attended almost every seminar that he could attend, and he asked plenty of questions, much to the chagrin of some of the speakers. He was always very supportive, but he never had a problem questioning other science, but he never did it in a mean way. And oh man, you could always, Hal always made sure you took advantage, and he always took advantage of going to the vendor show. I was a big proponent of free food. So if you ever needed to find Hal and he wasn't at a talk, it was always a good idea to check out the vendor show to see if he was there trying to score some ice cream or a cupcake or the free lunch. But that probably that one of the things Hal liked to talk about the most. But he was also extremely proud and really honored when he got acknowledged by his mentees. So Hal won the Rothenthal Award for the Department of Microbiology and Immunology for graduate student advocacy. And he was nominated by two of his then graduate students. They are now both PhDs. And when you win this award in the Department of Microbiology, you win what they call you get a statue of Beaker from the Muppets. And oh gosh, Hal had so much fun. I don't know how long he was in his office, posing Beaker around his office. And he and a longtime colleague and friend, Cindy Booth, were taking pictures of Hal pretending to teach Beaker how to count colonies, Hal having Beaker sitting at the computer. Oh, it was hilarious. And how Hal went on and on about how Beaker was very slow learning how to score colonies. And you know, Hal spent a lot of time, of course, with the accomplishment of developing cord blood transplantation as a source for stem cell transplantation. Hal was in the press a lot. Although, to tell you the truth, the press probably wasn't as important to him as the over 830 peer-reviewed papers he had out, but he was always chuffed to show you all some of the press that he had gotten. So, and you know how actually important some of that press was, because it encouraged that grandma who read it to help with the first, who suggested her child with leukemia be, or her grandchild with leukemia to get the first leukemia, I can talk today, the umbilical cord blood transplant for leukemia. But how through the years appeared in many press, including the Indiana Alumni Magazine and in the New York Times. And this paper, this press is one of the reasons why Hal liked doing these kind of things, these opportunities to be in the press, was because Hal really did not like scientific misinformation. This newspaper article was in response to a unscrupulous group of scientists who were pushing the use of, or making all these false claims that umbilical cord blood could be used to cure pretty much everything. And Hal did not like false claims or false scientific or unproven scientific claims being in the media. And it was giving umbilical cord blood a sort of bad name. And so this newspaper article in the New York Times was Hal's way of fighting that misinformation, because he talked about the pros and the cons of umbilical cord blood, but also emphasized what it hasn't really been, that these claims that people have been making about the use of cord blood, why they were false. But then spent the last half of this newspaper article talking about the good of the use of cord blood, specifically the importance of the fact that umbilical cord blood is actually a great source for those that are underrepresented groups that would have difficulty obtaining a good bone marrow donor match. But this is one of Hal's moments where he was also very proud. Hal actually had the BBC come to his lab to to build an hour-long documentary on cord blood called Lifeblood. And this Hal had this poster about the BBC coming to lab hung in his office since I've known Hal. And this documentary came out in 2000. And this BBC group came all the way over to Indianapolis and filmed this feature documentary. And Hal was very proud of this moment. But again, Hal was a very big proponent of fighting misinformation. And this turned into a interesting experience in my time in Hal's lab when we actually had a visit from Princess Fatma of Dubai and the CEO of Cord Use in 2016. Now, this princess was an interesting, not when you have an idea of meeting somebody from a royal family, you don't imagine them to be a biochemist, but Princess Fatma was. And she wanted to learn more about cord blood banking. And she wanted more information about the use of cord blood as a possible source of stem cells for transplantation. Because in the Middle East, she said there was a lot of misinformation about what these cord bloods, how these cord bloods were collected, not understand that a lot of the women and the men in the Middle East didn't understand that this was not like embryonic stem cells, that this was actually just medical waste pretty much that could be utilized in a clinical for a clinical purpose. And so she had come and spent the whole day with us in Hal's lab, learning all about cord blood, meeting all the people on the third floor of R2 over here in IU School of Medicine. And that was one of the more surreal days of my time in Hal's lab. But don't get me wrong, Hal did enjoy the press, but what really drove him was his research. And so I'm going to spend the last part of this talk talking a little bit more about Hal's research. Anybody that knows Hal knew talking about research made his day. I mean, if you really, what Hal really cared about was pursuing research, publishing research, and getting Grant to do more research. And he loved to go to meetings and learning about a bunch of other people's scientific findings. And when there was any controversy due to those findings, Hal made it a point to actually learn more about it. There was a lot of arguments at that meeting. In fact, one time Hal had invited somebody to come give a talk to his lab. So he flew him down to IU and he had him give a lab meeting to the lab and had him talk all about their findings, because Hal had known this particular researcher, I'm not going to name names, was having a lot of trouble convincing the larger scientific community to their findings. And Hal's like, well, if you could convince me in this lab meeting, I will help you. But unfortunately, Hal wasn't convinced by the particular talk, so he didn't end up pursuing a collaboration with that group. But Hal always gave people the shot to convince him. If he was convinced, he'd bend over backwards to help. But one of the main things Hal liked to particularly pursued in his laboratories were ways to improve umbilical cord blood as a donor source for hematopoietic cell transplantation. So as many of you guys are aware, there's many advantages of using umbilical cord blood as a donor source for HCT. Those advantages include less need for a perfect HLA match, easy to harvest without the risk to the newborn donor or mother, and decreased incidence and severity of graft versus host disease despite an HLA mismatch. There's many disadvantages also of using umbilical cord blood. There's a slower engraftment time, that's delayed immune reconstitution, meaning longer hospital stays, thus increased costs to the patient. Not all units contain sufficient hematopoietic stem cell and progenitor cells content for transplant to adult. And there's actually, because of that decrease in graft versus host disease, they also have a decrease in graft versus leukemia effect. So Hal's lab focused on 4 main strategies to improve umbilical cord blood hematopoietic cell transplantation, with the goal to use a single cord blood unit for transplant. And that was to improve methods of collection and processing of cord blood samples to preserve HSC numbers and function, expand stem cell numbers ex vivo so that there are more stem cells to transplant, enhance homing of the stem and progenitor cells to the bone marrow following transplant, thus shortening the time of engraftment, and ultimately minimizing recovery time. And when I say this was a major focus of Hal's laboratory or his collaboration with other laboratories, I can't be understating it. It really was. So as I said, there's the 4 main ways that Hal's lab focus: collection, expansion, engraftment, enhancing engraftment, and enhancing homing. And these are just some examples of Hal's contributions just from the 2000s. And these are not like even a comprehensive list. This is just touching on some of the ones that were focused, that were focusing mostly on improving hematopoietic stem cell from umbilical cord transplants. And you know, a lot of people especially in the last like 4 or 5 years, when would always ask me, when is Hal planning to retire? When is Hal planning to retire? But you know, knowing Hal, he was never planning to retire. And this couldn't be more emphasized by the fact that Hal still had clinical trial findings coming out in publication in 2021. And this is on his DPP4 work. And this came out in the New England Journal of Medicine with his longtime collaborator, Dr. Frog. But when we often think of Hal's contributions to the field of hematopoiesis and hematology as him being the father of the umbilical cord blood transplant. But we forget often that Hal played actually a pretty significant role in the field of mobilized peripheral blood as well. And his help in developing the drug AMD 3100, which is, as many of you guys know, is a CXCR4 antagonist that works to block the SDF, stromal-derived factor 1, CXCR4 retention signal in the bone marrow, allowing the stem cells to exit and go into the peripheral blood. But we also forget the importance of not just the role of the stem cells in umbilical cord blood be used as a transplantation donor source, but the role of the hematopoietic stem cells in umbilical cord as a source for research. Because if you look at many of the publications that examine human hematopoietic stem cell function, one of the most common sources, if not the most common source of those stem cells, is from the umbilical cord blood. And you think about how much hematopoietic stem cell research has moved forward because of the availability of these stem cells in umbilical cord blood. And that, to me, it's something saying something major about Hal's contributions to the field. And finally, when many of us think of Hal, we close our eyes and we picture Hal in our minds. And especially those that knew Hal, can visit him in his office. You can easily imagine Hal sitting in front of his microscope. And mind you, his very, very old but trusty microscope. With his handmade purple felt elbow pads that he utilized to stop the tingling from his funny bones from leaning on his desk. You picture Hal scoring colonies. And you picture him writing all those colonies with his special dark lead #2 pencils that he had special ordered for him and provided to him. because as many of you guys know, Hal did almost all of his grant writing, all scoring colonies, all of his marking of manuscripts, his writing of manuscripts, his writing grants. He wrote most of those using this particular type of number 2 pencil. And if it wasn't for April Maines, many of those grants wouldn't have become a typed out document. But that's how many of us remember pacing outside of his office, waiting for him to finish counting a plate so we can go in and talk to him, because we didn't want to interrupt him mid-count. That's the way I spent, I think, many of my times pacing in front of his door, trying not to disturb him, so that I can ask him a question or share some interesting data with him. But many of those times when I did go into his office to talk to him, it wasn't to talk to him about science. Although, of course, I spend most of my time talking to him about science. But Hal was a man of many passions, and that included weightlifting. In fact, I knew one of the former grad students from IU School of Medicine prior to coming or even meeting, having met Hal, because he was a PI in the lab next to mine when I was in grad school. His name was Scott Abrams. And Scott Abrams had told me he was a fairly shy graduate student. You know, he didn't have the greatest confidence, and Hal sort of took him under his wings and taught him how to do weightlifting. And they would spend many a weekend or evening weightlifting together. And those who have known Hal and heard Hal talk about this passion of his, Hal won the Masters Weightlifting National Championship in 1990 and 1994 for his age and weight division. Hal was also an active track and field participant. And I remember, I think the very first month in his lab, we used to wait around always in his lab for packages from FedEx. In fact, the FedEx guy called all of Hal's lab members his little vampires, because we were always waiting for cord blood, and we'd get really excited when cord blood would come in the mail. We'd be like, ooh, blood. And so we were his little vampires. But we had several packages that had come in, and man, these packages were just exceptionally heavy, and we couldn't figure out why. And we opened them up, and it's a shot put, and it's a javelin, and he had them sent to work instead of at home, because I'm not sure if he wanted Beth to know that he had been ordering all this stuff online. And as I mentioned earlier, Hal was an avid reader. He loved reading the history of different scientific discoveries, and this wasn't limited to hematopoiesis. He loved reading about Albert Einstein. He loved reading about Albert Einstein, but he read about physics, astronomy. He read about a whole bunch of other scientific fields. Hal attended every seminar he could possibly attend. He was a man that believed in diverse knowledge would make you have better ideas. And Hal was a big Elvis fan, and I'm not joking. He was a huge Elvis fan, to the point when we went to the Midwest Bug Club in Memphis, he took the whole lab to Graceland.
Well,
And it was a road trip.
to watch on how.
Sorry, what?
Weird, but I think
Hal was a big fan of Elvis. So we had all gone to Graceland. It was a 4-hour road trip that we decided we were going to rent a car to go to. And Hal had us listen to Elvis Presley songs the whole way up. Hal accidentally put one of those songs on repeat and then promptly fell asleep. So we ended up listening to the same Elvis song for about an hour and a half of that road trip. But it was a very fun, more memorable road trips of my life. He was also a big avid movie fan. He would love to exchange opinions on movies. Actually, loved to argue about those opinions on movies. But he and Beth had frequently attended movies together, and was something he really truly enjoyed doing. He was also an avid baseball card collector. he had actually a really huge collection of baseball cards that I was actually pretty envious of. But when I think about how really enjoyed in life, I mean, trust me, he was very dedicated to science and he had his many passions, but his greatest passion of all was his family. Hal survived by his loving wife of 52 years, Beth, and his two sons, Eric and Jeff, and his two grandbabies, which he was very proud. And I just like to end final two slides. Hal really truly loved being a part of the CCEH. He was the PI of our CCEH U54 grant here at IU for many years. And the final application and cycle, Hal and I were going to be core directors of a new core, the hypoxia core. Hal, one of Hal's latest love in his research lab was focusing on isolating stem cells under hypoxic conditions or low O2 conditions. So we can maintain the stem cells under their normal O2 levels of the bone marrow. We prevent them from undergoing oxygen shock, which would decrease the production of ROS and thus inhibit stem cells from differentiating into progenitor cells, thus preserving their ability to engraft and repopulate for long-term repopulation in the bone marrow. And Hal wanted to really focus on spreading the ability of people to do their research and understanding the true stemness of a stem cell by being able to isolate them and do their experiments under hypoxic conditions. I'm now running in that core by myself, which was what I initially thought I'd be doing. But it's my honor to try to continue Hal's passion about this work. So if anybody's interested in pursuing some of their research utilizing our hypoxia core, I strongly suggest, like Diane said at the very beginning, of visiting the CCEH.io website, where you can go and look up the different core facilities that are available to you through the CCEH. And strongly suggest you contact me. Be happy to help you with your initial experiments and help you try out your new ideas. Also, IU, in honor of Hal, has set up an IU, the Dr. Hal Broxmeyer Fellowship, where it will be supporting research fellows to do research in laboratory settings. If you want more information about this fellowship, I was asked to, I provided a website here and an email address for the woman who's organizing it. And with that, if you have anybody want to discuss their experience with Hal, I know many of you guys knew him for much longer than I had, but I can honestly say the 10 years of having Hal in my life probably been some of the most meaningful 10 years of my life. As my mentor, he was somebody who really helped me develop confidence in myself, has helped spark my enthusiasm for the field, because Hal was probably one of the most enthusiastic people I've ever met. He just loved what he did, and was very passionate about what he did, and it just oozed from him. He was just one of those people who made it easy to work for, because he just wanted to try everything. He wanted to know as much as he could, and was always willing to give you those opportunities to be able to do that. And so I just want to say that I wanted to thank Hal for everything he helped provide our field, and everything he helped provide all the people he helped to train and all those people he gave support and mentorship to. So with that, I would like to say thank you.
Great. Thank you, Megan. That was terrific. I just want to invite anybody who wants to show their face, ask a question, tell us a story. You are welcome to do it at this time and just kind of jump in if you want to. I had not known Hal for very long, just had interactions with him through the Centers of Excellence, but he was always kind, always kind. Yeah, and that was a really my very first impressions of him. And so he will be greatly missed in our community. Anybody else want to comment, ask a question, or tell a story that we don't know? Karen?
Hey, I just want to say, Megan, thanks so much for a great overview about how, as you know, I came to IU for a postdoc and was in Hal's department for a number of years and then switched over to the Wells Center. But Hal was one of those people that just kept in touch with all of us, no matter where our scientific journey took us. And I remember him coming up to me at a seminar once and saying, how's it going? We haven't talked in a while. I mean, he was just very genuine like that. So I really appreciate your overview very much. Thank you.
Great, thank you. Anybody else? Nobody has a silly story about Hal? I was thinking his microscope looked quite like my old microscope.
I think Scott still yeah, Scott still has that microscope.
Well, we actually gave it to Beth.
There you go.
We
Yeah.
thought maybe the grandkids would like it, so he brought it with him from Sloan Kettering, and yes, that's kind of a memento of their grandfather. So yeah, other than Lou Pellis and maybe I don't know who else is on here. I probably knew Hal longer than anyone. Everything Megan said is pretty much true. You left out all the yelling.
Yeah, well,
And Hal was a very demanding perfectionist, which was a good thing. Yeah, there wasn't that much yelling. There really wasn't. But he really demanded perfection, and I think a couple, you've said it, and Karen, you said it. He was just always very caring and never said no to anyone. Sometimes that created frustration in the lab because he'd always be bringing new people into the lab and no space to put them, or he'd be giving resources away to help somebody else, which means we got to figure out a way to get those resources back in. And he was just generous to a fault. So there will not be anybody else around here like him for a long time.
I love that. Thank you. Thank you for those comments. Okay, I think it's the hour. And so just again, thank you so much for the wonderful sort of overview of Hal's research life and his contributions. And I actually learned a lot. Now I've got to go read some really old papers that could be really fun to read.
oh yeah, I love the history of his field. I mean,
Sure.
he can go on and on. I love that part about having been in his lab.
Being old enough, I also love the history of science, especially. It's just interesting to see how people were successful and what the things that they had to do to be successful. And so that's fun. And now for the younger generations, they have to develop different skill sets, which is fun to watch. And just it'll be really great to watch Indiana go forward in the field of hematology that Hal has laid such great groundwork for. Okay, with that, we'll stop. Thank you all for attending and hope to see you next month for our next Meet the Expert seminar series. And again, thank you, Megan, for that wonderful tribute to Hal.
Thanks.
This is my clap, it's a real one. Good. Thanks so much and take care, everybody.